Okay, in this video we are going to go over the 6 exponent expressions that I presented at the beginning. And while we do that, of course, we'll basically integrate or cover simple rules and properties of exponents as we do so. Basically, everybody watching this probably already knows what an exponent is. It's simply some number or expression to an exponent. And the exponent represents how many times you're going to multiply the number by itself. For example, in this case, we have 2 to the 4th, so we're going to take 2 and multiply it by itself 4 times, and we get 16. A more generic view would be some number x to the 3rd power, which would be x times x times x. Okay, now before we get to the 6 questions that I gave you, I'll give you one more chance to look at them and write down your answers, and then we'll compare. Okay, let's look at the 6 examples I gave you. The first one is probably the easiest. It's pretty straightforward. It's simply 9 squared, and as we saw before, an exponent is simply represents how many times you're going to multiply a number by itself. 9 squared is simply 9 to the 2nd power. 9 times 9 is 81. So that's a very basic one. The second example is a little trickier. That one is 9 to the negative 2, and it is not negative 81. Somebody might say that. I've seen people try to guess 18, negative 9. It is not that. The best way to approach this is to look at a couple rules, and the first rule is the addition property. And the addition property is basically, or some people call it multiplication, so when you have two numbers of the same base and you multiply them against each other, you can simply add the exponents. And an easy example would be, let's say we had x squared and we want to multiply it times x to the 3rd. Okay, the shortcut is simply saying x to the 5th. We've added the 2 and the 3. A way to verify that is simply say, look, this is x squared, which is x times x, okay, and this is all times this x cubed, which is x times x times x. So we have 3 of these, 2 of these, which is a total of 5. So using that approach, I like to basically say, look, let's take the 9 to the negative 2. If we had 9 to the negative 2, and we decide to multiply it by 9 squared, which we just found in the previous example, we should equal 9 to the 0, because we're adding the 2 exponents. If that's the case, any number to the 0 power that's not 0 is always equal to 1. Therefore, this has got to be equal to 1. And we know this is 81. Therefore, 9 to the negative 2 is simply the reciprocal of 81. Then the next pair of questions I asked dealt with numbers that have fractional exponents. And there are rules to find the answers to these values, but what we'll do is we'll try to keep it simple and go back to our addition property, which basically said that if you have two numbers with the same base and different exponents, you can simply add the exponents when you're multiplying them. So let's take a look at this one. We have 9 to the 1/2, 9 to the 1/2, which is basically the same thing as 9 to the 1/2, and we add the exponents, which of course equals 9 to the 1st power. And everyone pretty much knows 9 to the 1st power is simply 9. So now our question has basically been reduced to what number multiplied by itself equals 9? And of course, most people would know it's simply 3. 3 times 3 is 9. And another approach would have been simply to say 9 to the 1/2 is simply the square root of 9, which is 3. So the answer to the third question was 3, which leads to the fourth question, which is, what is 9 to the negative 1/2? And 9 to the negative 1/2 is another approach. Again, don't multiply these. It's not 4.5. It's not negative 3, whatever. Again, we go back to the same principle that a negative exponent is simply reciprocal and can be simply written as 1 over that number. And since we just found from the other problem that 9 to the 1/2 is 3, 9 to the negative 1/2 must simply be 1/3. Okay, so hopefully you got that one right. And then we'll move on to our last pair of exponent expressions. The last pair of numbers, exponent numbers I gave you, were 5 squared. And of course, 5 squared is 25. But the big question is it positive or is it negative? The first example was negative 5 squared. And it's important to rewrite this as negative 1 times 5 squared. And you'll see why in a second. It basically differentiates the exponent from the multiplication property and separates this negative from the 5 squared. And a lot of you are familiar with the term PEMDAS, which is an abbreviation for parentheses, which there's one, exponent, multiplication, division, addition, subtraction. And it basically is a way to remember how to utilize order of operations. And in this exponent case, we actually have two operations going on here. We have the exponent operation followed by the negative, which is the multiplication operation. And this is really negative 1 times 5 squared, in which case this becomes negative 1 times 25. And so our answer is negative 25. Okay, so the answer to the fifth example is negative 25. And of course, then we move on to our final example, which is a little bit more direct, which is simply negative 5 squared. And again, we have a parentheses in there. And an even better way to look at this is simply to say, look, this is two numbers multiplied by themselves. So negative 5 times negative 5. And of course, negative times a negative is a positive. Therefore, this final answer is positive 25. So that's the answer to the final two. Hope you got all 6 of them. If not, do a little bit more practice reviewing the properties of exponents, and we'll give it a try next time.